Okay, so let us have here the domain and the range. Okay, so like we have mentioned already, domain class is the values of x, or these are set of numbers that defines our function. Okay, so all values of x that could satisfy our equation f of x. Take note, all possible inputs for the function. So you will think, what value of x, or what value or what number can satisfy this equation or this function? Okay, it refers to the domain. Like for example, your given function is f of x, so therefore you will think of the values of x. But like we said, class, not all the time is we are using the f of x. There are times that other books uses other letters like g of x, or it could be it's a function of time, it could be it's a function of s. Okay, but most of the time it is function of x, where you are to think of the values of x as your inputs. Now, how about the range? If domain is the value of x, then range is the possible resulting value, or simply the result. Okay, if your input is x, then your output will be your f of x, or it will be our dependent variable, or our y. Okay, so if you have the range, if this is the values, if this is the possible inputs, so what will be the possible output? Okay, that's the question here in the range. So to understand this more clearly, class, we have here an example. Okay, for example, we are given this function of x, which is equal to 1 over x squared. Okay, now we are asked, what are the domain and what are the range? Okay, let us start with the domain. Okay, so in order for us to solve for the domain, so if we go back to the equation, 1 over x squared, so you will think, you will ask yourself, what values of x can satisfy, or possible to be inputted here, or can be used here? So take note that your x, variable x, is at the denominator. Okay, so if it is in the denominator, therefore all numbers can be used, right? All real numbers, except what number? Except 0. Why? It's because if we divide a number by 0, we have learned that it is undefined, or cannot be determined, or equivalent to infinity. So therefore, what can you conclude from here? That you cannot use 0. So all real numbers except 0. There, as you can see, our set of numbers is x, such that x is not equal to 0. Can you see it? Did you see it? This one here. X is x such that x is not equal to 0, which means you can use negative numbers, you can use positive numbers. Okay, so that is your domain. Those will be your possible values of x that should be used in that equation. Now, how about for the range? Now, solving for the range, class, you need to ask yourself, if my possible values of x are all real numbers except 0, then what will be your output, or what will be the result if you substitute those numbers to your equation? So again, our equation here is f of x is equal to 1 over x squared, right? Which is, this f of x is equal to your y. So therefore, y equals 1 over x squared. So the question is, what is your possible outputs? So you are thinking here for the values of y. Okay, so y equals 1 over x squared. So if my x, or if the value of my x is all real numbers except 0, so what will be the resulting y? Okay, so take note, if we rearrange the equation, x squared equals 1 over y. Take note, class, that this formula here, this one came from here. This one here. Okay, all you did was cross multiply here. So what will happen? X squared is equal to 1 over y. Okay, now let us analyze this equation here. This one. Okay, if you analyze, what values of y should you use so that it will satisfy this equation? As you can see, in this situation, your y is at the denominator also. So what can you think? You think that you cannot, what? You cannot still use 0, which means you can use positive, also the negative. Okay? So if, for example, you use the positive numbers, is it okay? Is it okay? Will it satisfy the equation? Yes. But then the question is, what if you use negative? Can you use negative? Because, well, like we've said, our possible values of x can be positive and negative, right? Except 0. So the question now here is, what will be the output if you inputted positive numbers and negative numbers? What will be the result? What will be the resulting y? Okay? Now, like we've said, we cannot use the 0. How about the positive? Yes, we can. Okay? But the question is, can we use the negative? Now, that's the question, class. We cannot use the negative numbers in this case. Why? Okay. Let's try substitute a number which is negative. Let's say y is negative 4. Okay? Let's say 1 over negative 4. Okay? So the equation will become this one. So x squared equals 1 over negative 4. Now, can you take the value of x? Which means, can you solve for the values of x? If you recall, we can only solve the value of x here by getting the square root both sides of the equation, right? So in here, x is equal to square root of negative 1/4, right? But then, you remember, isn't it impossible that there's a square root of a negative number? Right? It's because square root of a negative number is imaginary. There's no real number in there. So therefore, we cannot do it. So what can you conclude from here? We can conclude here that your y, okay, your y should only be greater than 0, which means all positive real numbers. Okay? So although our domain is both positive real numbers and negative real numbers, but your output or your range is only positive real numbers. Okay? So in this case, to answer your range will then be x such that, or all real numbers, or x such that your x should be greater than 0. So this is your answer for the range. But for the domain, your answer should be x such that x is not equal to 0, which means both positive and your negative. But when it comes here in range, your x now should be greater than 0 only. Okay? So that's our that's how we determine the domain and the range.